Hey folks, let's look at an example of how to find probabilities associated with a sample proportion. In a town of 48,500 residents, 31,040 are registered to vote. Suppose we randomly select a sample of 50 residents. Notice here that in essence, we're starting with a binary situation. There are two outcomes, and a success would be when an individual is registered to vote. A failure would be that they are not registered to vote. Based on this info, let's identify the parameters that have been given. We have a sample size of 50 residents, so that is n. And what would p be? Well, that would be the chance that any one individual is registered to vote. We weren't given that info directly, but we can use this info about how many people are registered out of the entire population, and that would be our estimate for population proportion. Let's check what this value is as a decimal representation. It might be easier for us in that context. 0.64. Before we compute probabilities, let's describe the sampling distribution for sample proportions of sample size 50 from this population. To do that, we will discuss the shape, the center, and the spread of this distribution. We had mentioned in the previous video that we want to work with normal distributions when possible, and there are certain criteria that allow us to do so when we have proportions that we're working with. Make sure that these criteria are satisfied so we can end up using the z-table and so forth. Since n is 50 and p is 0.64, we just want to multiply those together to check that it's at least 5. And same thing over here, 50 times 1 minus 0.64 is also at least 5. 50 times 0.64, definitely bigger than 5, and also bigger than 5, so that's great. I would like to show you a visualization of why that criteria has been established. Here is a graphical tool. You can feel free to look it up if you want, and it's just going to graph binomial probabilities based on certain inputs that you've given. These are the values in our problem that we're working with. As you can see, on the x-axis, those are whole numbers because those are the number of successes. Remember, binomial, number of people who are registered. And these bars are the probabilities of those x's. And they look pretty bell-shaped, right? Because we met that criteria. However, if I inputted a different value for p here, maybe about 0.1, 0.1 times 50 is exactly 5. So it's not greater than 5. So this might not look very bell-shaped. It has some bell characteristics, but it does have a very long right tail. It's right skewed. And that would definitely not be met if the sample size was any smaller. Here I've done sample size 20 with probability 0.1. Here this is very right skewed, and so we wouldn't be able to like overlay a normal distribution here and use that as an accurate way to get probability. So that is why we have that criteria. When that criteria is met, then those binomial probabilities appear normally distributed. Since we met the criteria for a normal distribution, I'm going to draw one here. To label it appropriately, I would call this axis p hat. the proportion of folks who are registered to vote in this town. Now that we have a normal distribution, it's reasonable to ask, where is the center of that distribution? In the previous video, we said that the mean of these p hats, the mean of the sample proportions, would be just the population proportion. But that value is given up here. So I can write 0.64 as the mean of this distribution, and I will also put that over here. The next item to discuss would be the spread, or the standard deviation of the sample proportions, also known as standard error. And that was given by p times 1 minus p over n, and that's all in the square root. Let's calculate that for this scenario. I'm going to write it out. P is 0.64. 1 minus 0.64 over 50. And this all needs to be inside the square root. To compute this, I'm going to use the calculator here, and a couple comments that this is going to be a small number. We're talking proportions, another way to think of a probability. Probabilities are between 0 and 1. So we're talking about the spread on something that's already usually considered a small number. So I've got p times parentheses 1 minus p. I don't know if I entered that correctly there. Divided by 50, close parentheses. Okay, so like I mentioned, a pretty small value. If I wanted to put a few tick marks onto this graph to represent one standard deviation to the left or to the right of that center, I would type the mean minus one standard deviation. And I might just do one tick mark because this might get a little messy. And then I would also do the mean plus one standard deviation. And that can guide us in drawing this image with a little bit more detail. I just put those in there so it would be a nice reference. Now let's go and compute a probability. I have a question here. Find the probability that in a sample of 50 residents, 29 or fewer are registered to vote. Because we can use that normal curve, we can use a z-score to help us find this probability. And we've already done a fair amount of this work. Notice the denominator that I'm writing, that is that square rooted quantity. We already calculated it up here. It's about 0.067. We also know what p is. We need to discuss what is p hat. What is p hat? Now that is the sample proportion, and that's referring to the proportion of successes. Here they say that we want to find the chance that 29 or fewer residents are registered to vote. That is our sample proportion. That would be the 29 out of the 50. Let's get a decimal for that. 0.58. So this is the sample proportion of interest. That's what's going to get plugged in to this z-score over here. And we now know all the other bits and pieces. So let's calculate this z-score. Plugging in the numerator, p with a hat is 0.58. The minus p That was the 0.64 from the top of this example. It's also written right here. In the denominator, this big square rooted amount, well, we've already done all that work there. No need to reinvent the wheel. I will maintain a lot of these decimals so I don't lose any info. Let's calculate this with our calculator. Our z-score is negative 0.8838. What I wanted to do a minute ago but had forgotten is I wanted to draw this 0.58 onto that image up above. I'm going to scroll up. 0.58 would be right around here, yeah? 0.58. We are finding the probability that the proportion is that many people or fewer in this population, or in this sample of 50. So we want to find this area. Since we have just identified the z-score that connects to that proportion, we can now take that z-score to the z-table. Recall that the z-table only allows us to enter 2 decimals worth of precision. So when I go to the z-table, I'm really going to look up negative 0.88. Remember to round that accordingly. Here's the z-table. You've got a copy on purple paper, but it's also posted on our websites. And I'm looking for negative 0.8. And then the column that also says 8. I know that the last column says a 9. I'll go double check. Yes. So I want the column that says 0.08 matched up with this row. So that's our answer, 0.1894. If we were to write this with probability notation, I might write instead that the probability that the proportion is less than, you could write 0.58, you can write 29 out of 50, doesn't really matter. I'm going to say equals this. Let's do another example. Let's find the probability that at least 80% of people are registered to vote in a sample of 50. So we're going to use all the same info from earlier, and we're going to use the same approach. We're going to find a z-score, take that z-score to the z-table, and get our probability. What do you notice, though, that's different about these two questions? In the first one that we've done, we were told a certain number of people that are registered to vote, and we turned that into a proportion. Here, we are already given a proportion, so we don't have to do that division. Also, we are asked a probability that says at least 80%. If I was to illustrate that in our image above, I would put 80% probably over here, 0.80. And the question asks for us to find the probability that at least 80% are registered to vote. So we would want this shaded region to the right. Keep that in mind. So let's do the z-score. Then we go to the z-table, and then we get our probability. Because this was an area to the right, we were told at least. When we go to the z-table to get our probability, remember we're going to have to do a 1 minus. Let's do it. Our z-score, it starts off with the proportion of interest so that's 0.80. We will subtract the population proportion of 0.64 and then divide by that square rooted amount. I think I can still see it up there, 0.0678882251. Let's compute this z-score. This will be a positive z-score of about, let's round this appropriately, that should be 2.36, right? Now let's go to the z-table and look up 2.36. So I'm on the positive side of this table. I'm going to go to 2.3 and I'm going to start counting columns 0, 1, 2, 3, 4, 5, 6. The probability that we need to extract from our z-table, 0.9909. But that can't be the answer, right? Because we need the at least probability. And that's why these pictures can be so valuable, because we have seen that we need to look at that right side. And there's no way that this area in pink can be a 0.99. It looks like a very small area. So we need to do 1 minus 0.9909 to get a very small probability, 0.0091. In the probability notation, I would write this as the probability that the proportion of registered voters is at least 80% is 0.0091. Let's take a brief moment to analyze this value. Wouldn't you agree that that's a very low probability? Therefore, it's unlikely that a sample of 50 residents would result in at least 80% being registered to vote. Supposedly, the population proportion was only 64% of residents were registered to vote. So that's why it would appear so unlikely to get a sample with over 80% registered, because there's only apparently 64% of the population that's registered. That will conclude this video. Hopefully it was useful. We showed how to implement this z-score formula as applied to proportions to find probabilities for those sample proportions. We'll do another example in the next video.